that?
All right, so today what we're going to be working on is absolute value equations. So the first thing I want you to do is write down what you think the definition of absolute value is, and then try these problems down here, and come back and check your answers. Okay, so the definition of absolute value is the distance from 0 to a number on the number line. So, for instance, let's say we have this number line. Here's 0. And let's say I put 5 here and negative 5 here. So the distance from 0 to 5 is 5. The distance from 0 to negative 5 is also 5. That's the reason why absolute value your answer is always positive, because we're talking about distance, and when you talk about distance, you can't have a negative distance. Distance is always positive, right? It would be 5 units going to the right. That's how far 0 is to 5, and it's 5 units going to the left. 0 to negative 5 is 5 units. All right, so let's take a look at number 1 here. It says, what's the absolute value of 4? Which means, how far is 4 from 0 on the number line? It is 4 units from 0. How far is negative 4 from 0 on the number line? Negative 4 is 4 units from 0 on the number line. All right, so now let's take a look at this. I have the absolute value of x equals 3. So what could x be? So what is 3 units from 0 on the number line? Well, x could either be 3, right? 3 is 3 units from 0 on the number line, or x could be negative 3. Negative 3 is also 3 units on the number line. Okay, so what's inside here can be that number, positive or negative. All right, so now we're going to talk about absolute value equations that are a little bit more complicated than what we have for number 3. Okay, so let's talk about the procedure. The first thing you always do, just like what we did with radical equations, we isolate the absolute value, which means to get the absolute value all by itself. Nothing in front of the bars, nothing behind the bars. Now, you're going to set up 2 equations. One equation is what you have at this point, and one equation is for the inverse. The inverse means you change all the signs, but you only do it to one side of the equal sign. You don't do it to both sides of the equal sign. Then you're going to solve both, and then you're going to check. You always have to check these, because you can get extraneous roots. So we're going to take a look at number 1. Okay, so the first thing I'm looking for with number 1 is to make sure the absolute value is isolated, which means there's nothing in front of the bar and nothing behind the bar except the equal sign. And that is good. So now I'm going to branch this off. I'm going to set up 2 equations. So notice, look what I'm writing. I'm branching it off. I'm going to have a branch to the left, and I'm going to have a branch to the right. The blue branch and the red branch. My blue branch, I'm just going to rewrite this the way it is because it's isolated. So it'll be x minus 4 equals 3. On the red branch, it's going to be x minus 4 equals negative 3. Because remember, what's inside the absolute value is going to be, it has to be equal to 3 or it has to be equal to negative 3. That's why I set up, sorry, this is supposed to be negative 3. That's why I set up 2 equations. It's what's on the outside, the positive in the blue, what's on the outside, the negative. All right, now you're going to solve each one of these. So add 4, and I'm also going to draw a bar down here to keep them separated. Add 4 to both sides here. So I get x equals 7 because the 4's cancel. And on the right side, I'm going to add 4. Negative 3 plus 4 equals positive 1. All right, now you do have to check. So write down the original problem. The absolute value of x minus 4 equals 3. Write it on both sides. Remember, look what I wrote, positive 3. I'm always, when I check original. Okay, now we're going to do substitute each one in and solve it. Make sure it works. All right, so in the blue, when x is equal to 7, so it's the absolute value of 7 minus 4, does it equal 3? It's like question mark. Is this true? Do what's inside the absolute value. So 7 minus 4 is 3, so it's the absolute value of 3. Does that equal 3? The absolute value of 3 is 3, so 3 equals 3, and that checks. All right, now we're going to try x equals 1. So it's the absolute value of 1 minus 4. Does this equal 3? It's question mark. Is this true? So I have do what's inside the absolute value. 1 minus 4 is negative 3, so it's the absolute value of negative 3. Does this equal 3? Yes, the absolute value of negative 3 is 3, so 3 equals 3, and that checks. All right, so let's try number 2. Okay, so I have the absolute value of 2x plus 3, a plus 5 on the outside, equals 20. So is my absolute value by itself on the left side? No. I have a plus 5 here, so I have to move the plus 5 to the other side. So I'm going to minus 5. So positive 5 minus 5 is 0. So it's the absolute value of 2x plus 3, don't forget your bars, equals 15. Now it's isolated. Now I'm going to set up one equation exactly how it is right now in your isolated form. So 2x plus 3 equals 15. And then we're going to set up the other side. The inverse, 2x plus 3. Notice I didn't do anything inside. And I'm going to make this negative 15 on the outside. Now we're going to solve each one. So in the green, minus 3. 2x equals 12. Divide by 2. X equals 6. And I'm just going to draw a bar to separate. On the right side, minus 3. 2x equals negative 18. Divide by 2. X equals negative 9. All right, so now we do have to check. So write the word check here. Remember, we always check original. So write that down on both sides. Absolute value of 2x plus 3 plus 5, does that equal 20? Write it down on both sides. 2x plus 3, absolute value, plus 5, does that equal 20? All right, so let's start in the green when x is 6. Bar, 2 times 6 plus 3, close the bar, plus 5, does that equal 20? Do what's inside the absolute value first. So it's the absolute value of 12 plus 3 plus 5. Does that equal 20? The absolute value of 15 plus 5. Does that equal 20? The absolute value of 15 is 15. So 15 plus 5 equals 20. Yes, 20 equals 20. Check. All right, now we're going to try 9. Negative 9, sorry. So we have, let me just draw my bar a little bit further down. The absolute value of 2 times negative 9 plus 3 plus 5, does this equal 20? Do what's inside the absolute value. So 2 times negative 9 is negative 18 plus 3, close the absolute value, plus 5 equals 20. So we have the absolute value of negative 15, right? Because negative 18 plus 3 is negative 15, plus 5 equals 20. The absolute value of negative 15 is 15, plus 5 equals 20, so 20 equals 20, and that checks. All right, so let's flip it over, and we could get a little bit more complicated. Okay, so number 3. I have the absolute value of x plus 6 equals 2x plus 18. So notice the right side is actually a binomial. Notice on the left side with the absolute value, this is isolated. There's nothing in front of the bar. There's nothing behind the bar except the equals. All right, so then we are actually ready to separate this. All right, so on the left side, I'm going to write it exactly how it is because my absolute value is isolated. So I have 2x plus 6 equals 2x plus 18. Now I need the opposite, the inverse. So I'm going to have the x plus 6, right? I didn't change this. I have to change this. When you change a binomial, you have to change the whole thing to its opposite. So positive 2x becomes negative 2x, and positive 18 becomes negative 18. Now we're ready to solve. All right, in the blue, I'm going to minus x from both sides, because I always like to move the smaller x. So I get 6 equals 2x minus 1x is x plus 18. Minus 18 from both sides. 6 minus 18 is negative 12. Now in the red, negative 2x is smaller than x, so I'm going to add 2x. So I get 3x plus 6 equals negative 18. Minus 6, 3x equals negative 18 minus 6 is negative 24. Always be careful of your signage. Divide by 3, x equals negative 8. Okay, now we have to check. All right, so write down the word check. Remember, we're writing down the original. I just have to go back and look at the original. So it's the absolute value of 6, x plus 6. So write that down. Absolute value of x plus 6 equals 2x plus 18. Sorry, 18. Okay, write it down on both sides. The absolute value of x plus 6 equals 2x plus 18. All right, so let's start in the blue when x is equal to negative 12. All right, so bar negative 12 plus 6, close the absolute value, equals 2 times negative 12 plus 18. All right, do what's inside the absolute value. Negative 12 plus 6 is negative 6, still inside the absolute value, equals negative 24 plus 18. The absolute value of negative 6 is positive 6. Negative 24 plus 18 is negative 6. This does not work. So make sure you cross negative 12 out. It's not a solution. Now we're going to try negative 8 in the red. Absolute value of negative 8 plus 6 equals 2 times negative 8 plus 18. Do what's inside. Negative 8 plus 6 is negative 2 in the absolute value. Negative 2 times 18 is negative 16 plus 18. The absolute value of negative 2 is positive 2, and negative 16 plus 18 is 2. So that checks. All right, we got one more to do, one more to practice. So this is kind of like all of them put together. So if you could do this, you understand this one, you're pretty good to go. All right, so I notice I have 2 on the outside of the absolute value. That means 2 times because there's no operation in between the 2 and the bar. So remember that means times. The absolute value of 3x plus 2 plus 1 equals 2x plus 5. So we are definitely not isolated here. All right, so we're going to start with the plus 1. We have to move that over, right? So remember, when we have, let's say, 2x plus 1 equals 2x plus 5, what would we move first? We would minus the 1. So same thing, minus the 1 because the times comes after. Minus 1 from both sides. So I have the 2 on the outside of the absolute value bar. Then the absolute value equals 2x plus 5 minus 1 is 4. Now we have to get rid of this 2 times. So we divide by 2. Now make sure you divide everything by 2. So the 2's reduce. So it's the absolute value of 3x plus 2 equals, the 2's reduce, and 4 over 2, that reduces to 2. All right, so now I'm isolated, so now I can make the 2 equations. So I'm going to have the green equation exactly how it is now that it's isolated. So 3x plus 2 equals x plus 2. And the inverse, so 3x plus 2. Now this is the inverse. Whole thing becomes opposite, negative x minus 2. All right, now we're ready to solve. I'm going to start solving in the green. Minus x from both sides. 3x minus 1x is 2x plus 2 equals 2. Minus 2. 2x equals 0. Divide both sides by 2. 0 divided by 2, 0 divided by any number is equal to 0. All right, in the yellow, I'm going to add x. 3x plus 1x is 4x plus 2 equals negative 2. Minus 2. 4x equals negative 4, negative 2 minus 2. Divide by 4, x equals negative 1. Okay, now we're ready to check, so write the word check. Write down the original. So it's 2 times the absolute value of 3x plus 2. And then it was plus 1. Equals 2x plus 5. I'm just going to recheck that. Yep. Okay, write it on both sides. So we have 2 times the absolute value of 3x plus 2 plus 1 equals 2x plus 5. Now we're going to check. All right, so let's see here. We have 2, the absolute value of 3 times x, which is 0, plus 2, plus 1, now I'm on the outside of the absolute value, equals 2 times 0 plus 5. All right, do what's inside the absolute value first. So we have 3 times 0 is 0 plus 2, plus 1 equals 2 times 0 is 0 plus 5. All right, keep going. So we have 2 times the absolute value. 0 plus 2 is 2. Plus 1 on the outside equals 0 plus 5 is 5. Remember, this is times here, but you have to do the absolute value first. So it's 2 times the absolute value of 2 is 2. Plus 1 equals 5. 2 times 2 is 4. Plus 1 is 5 equals 5. So that checks. All right, now we're going to try the negative 1. So it's 2, the absolute value of 3 times negative 1 plus 2. Now I'm on the outside of the absolute value, plus 1 equals 2 times negative 1 plus 5. All right, we're going to take care of the absolute value here. So it's 2 times the absolute value. 3 times negative 1 is negative 3 plus 2. Now on the outside, plus 1 equals 2 times negative 1 is negative 2 plus 5. So we have 2 times the absolute value of negative 3 plus 2 is negative 1. I'm outside the absolute value, plus 1 equals negative 2 plus 5 is 3. All right, now we do the absolute value. So it's 2 times the absolute value of negative 1 is positive 1. Plus 1 equals 3. So now let's finish this up. So it's 2 times 1 is 2. 2 plus 1 is 3 equals 3, and that checks. Okay, so that's it, and we'll practice in class tomorrow. Everybody have a good night.